Welcome everyone. I am Shifa from 6M MCA and here I am going to present the topic cloud computing. In this presentation I include introduction, what is cloud computing architecture, basic concepts which include deployment models. It contains public cloud, private cloud, community cloud and hybrid cloud. Second, service models which contains infrastructure as a service, platform as a service, software as a service and data as a service. Security and privacy issue of cloud computing, security on demand, cloud applications, advantages, disadvantages, conclusion and finally the references. Here I am going to just introduce the topic cloud computing. Cloud computing is a whole new technology. Cloud computing provides as a means by which we can access the applications as utilities over the internet. It allows us to create, configure and customize applications online. With cloud computing, users can access database resources via the internet from anywhere for as long as they need without worrying about any maintenance or management of actual resources. It is the development of distributed computing, parallel computing, grid computing and is the combination of virtualization, software as a service, utility computing, infrastructure as a service and platform as a service. Cloud is a metaphor to describe web as a space where computing has been pre-installed and exists as a service. Data operating system, applications, storage and processing power exist on the web ready to be shared. For users, cloud computing is a pay-per-use on demand mode that can conveniently access shared IT resources through the internet. Where the IT resources includes network, server, storage, application, service and so on and they can be deployed with much quick and easy manner and least management and also interacting with the service providers. Cloud computing has recently reached popularity and developed into a major trend in IT. While industry has been pushing the cloud research agenda at a high pace, academia has only recently joined as can be seen through the sharp rise in workshops and conferences focusing on cloud computing. Cloud computing has improved the availability of IT resources and owns many advantages over other computing techniques. Users can use the IT infrastructure with the pay-per-use on demand mode. This would benefit and save the cost of buying the physical resources that may be available. Next, what is cloud? The term cloud refers to a network or internet. In other words, we can say that cloud is something which is present at remote location. Cloud can provide services over network, that is on public networks or on private networks, that is WAN, LAN or VPN. Applications such as email, web conferencing, customer relationship management, CRM all run in cloud. Next, what is cloud computing? Cloud computing refers to manipulating, configuring and accessing the applications online. It offers online data storage, infrastructure and application. Cloud computing is both a combination of software and hardware based computing resources delivered as a network service. Next, the cloud computing architecture. Cloud technology models are generally divided into SaaS, PaaS and IaaS that are exhibited by a given cloud infrastructure. It is helpful to add more structure to its service model stacks. This given figure shows a cloud reference architecture that makes the most important security relevant cloud components explicit and provides an abstract overview of cloud computing for security issue analysis. Next, the basic concepts of cloud computing. There are certain services and models working behind the scene making the cloud computing feasible and accessible to end users. Following are the working models for cloud computing. These are deployment models and service models. First one, deployment models. Deployment models define the type of access to the cloud, that is, how the cloud is located. Cloud can have any of the four types of access: public, private, hybrid and community. First, public cloud. The public cloud allows system and services to be easily accessible to the general public. Public cloud may be less secure because of its openness. Example, email. And the benefits of public clouds are minimal investment. As a pay-per-use service, there is no large upfront cost and is ideal for businesses who need quick access to resources. No hardware setup. The cloud service provides fully fund the entire infrastructure. No infrastructure management. This doesn't require an in-house team to utilize the public cloud. And limitations of public cloud, data security and privacy concerns. Since it is accessible to all, it doesn't fully protect against cyber attacks and could lead to vulnerabilities. Reliability issues. Since the same server network is open to a wide range of users, it can lead to malfunction and outages. And last, service and license limitation. While there are many resources you can exchange with tenants, there is a usage cap. Second one, private cloud. The private cloud allows systems and services to be accessible within an organization. It offers increased security because of its private nature. Benefits of private cloud includes data privacy, security, support legacy systems. Data privacy. It is ideal for storing corporate data where only authorized personnel gets access. Security. Segmentation of resources within the same infrastructure can help with better access and higher levels of security. Supports legacy systems. This model supports legacy systems that cannot access the public cloud. Limitations of private cloud. Higher cost. With the benefits you get, the investment will also be larger than the public cloud. Here, you will pay for software, hardware, and resources for staff and training. Fixed scalability. The hardware you choose will accordingly help you scale in a certain direction. High maintenance. Since it is managed in-house, the maintenance cost also increase. Third one, community cloud. The community cloud allows systems and services to be accessible by group of organization. Benefits of community cloud. Smaller investment. A community cloud is much cheaper than the private and public cloud and provides great performance. Setup benefits. The protocols and configuration of a community cloud must align with the industry standards, allowing customers to work much more efficiently. Limitations of community cloud. Shared resources. Due to restricted bandwidth and storage capacity, community resources often pose challenges. Not as popular. Since this is a recently introduced model, it is not that popular or available across industries. And the last one is hybrid cloud. The hybrid cloud is mixture of public and private cloud. However, the critical activities are performed using private cloud while the non-critical activities are performed using public cloud. And the benefits of hybrid clouds are cost effectiveness. The overall cost of a hybrid solution decreases since it majorly uses the public cloud to store data. Security. Since data is properly segmented, the chances of data theft from attackers are significantly reduced. Flexibility. With higher levels of flexibility, businesses can create custom solutions that fit their exact requirements. Limitations of hybrid cloud. Complexity. It is complex setting up a hybrid cloud since it needs to integrate two or more cloud architectures. Specific use data. This model makes more sense for organizations that have multiple use cases or need to separate critical and sensitive data. Next topic is service models for cloud computing. Service models are the reference models on which the cloud computing is based. These can be categorized into three basic service models as listed below. First one, infrastructure as a service, that is IaaS. Second one, platform as a service, that is PaaS. And third, software as a service, SaaS. And last one, data as a service, DaaS. First, infrastructure as a service. IaaS is the delivery of technology infrastructure as an on-demand scalable service. IaaS provides access to fundamental resources such as physical machines, virtual storage, etc. Cloud consumers directly use IT infrastructures, that is processing, storage, networks and other fundamental computing resources provided in the IaaS cloud. Virtualization is extensively used in IaaS cloud in order to integrate or decompose physical resources in an ad hoc manner to meet growing or shrinking resource demand from cloud consumers. The basic strategy of virtualization is to set up independent virtual machines that are isolated from both the underlying hardware and other VMs. Usually built based on usage, usually multi-tenant virtualized environment and can be occupied with managed services for operating system and application support. These are some of the examples of infrastructure as a service. This includes OP Source, GQ Grid, Amazon EC2, Blizzard, Entity Communication, Termark, and T. Next one, platform as a service. PaaS provides the runtime environment for applications, development and deployment tools, etc. PaaS provides all of the facilities required to support the complete lifecycle of building and delivering web applications and services entirely from the internet. Typically, applications must be developed with a particular platform in mind. PaaS is a development platform supporting the full software lifecycle, which allows cloud consumers to develop cloud services and applications directly on the PaaS cloud. PaaS offers a development platform that hosts both completed and in progress cloud applications. These include multi-tenant environments and highly scalable multi-tier architecture. And here are some examples of PaaS. These includes Amazon Web Services, Azure, Google App Engine, Salesforce.com, Join, Rackspace, and Terra, etc. Next, software as a service. SaaS model allows to use software applications as a service to end users. SaaS is a software delivery methodology that provides licensed multi-tenant access to software and its functions remotely as a web-based service. Cloud consumers release their application in a hosting environment which can be accessed through networks from various clients, example web browser, PDA, etc. by application users. Cloud consumers do not have control over the cloud infrastructure that often employs multi-tenancy system architecture, namely different cloud consumers applications are organized in a single logical environment in the SaaS cloud to achieve economies of scale and optimization in terms of speed, security, availability, disaster recovery and maintenance. These include usually built based on usage and highly scalable architecture. And these are the some of examples of SaaS. This includes Salesforce.com, NetSuite, Postini, and Google Mail and Google Document, etc., Facebook. And data as a service. The delivery of virtualized storage on demand becomes a separate cloud service, data storage service. The motivation is that on-premise enterprise database systems are often tied in a prohibitive upfront cost in dedicated server, software license, post-delivery services and in-house IT maintenance. DaaS allows consumers to pay for what they are actually using rather than the site license for the entire database. In addition to traditional storage interfaces such as RDBMS and file system, some DAS offerings provide table-style abstractions that are designed to scale out to store and retrieve a huge amount of data within a very compressed time frame, often too large, too expensive, or too slow for most commercial RDBMs to cope with. And these are the examples of DaaS, includes Amazon S3, Google Bigtable, and Apache HBase. These are some of the examples of cloud which we can use. Next, security and privacy issues of cloud computing. Cloud computing can provide infinite computing resources on demand due to its high scalability in nature, which eliminates the need for cloud service providers to plan far ahead on hardware provisioning. Many companies such as Amazon, Google, Microsoft, and so on accelerate their paces in developing cloud computing systems and enhancing its services, providing to a larger amount of users. Security and privacy concerns provided by companies nowadays are not adequate and consequently result in a big obstacles for users to adapt into the cloud computing systems. Hence, more concerns on security issues such as availability, confidentiality, data integrity, control, audit, and so on should be taken into account. Next topic, security on demand. Cloud services are applications running somewhere in the cloud computing infrastructures through internal network or internet. Cloud computing allows providers to develop, deploy, and run applications that can easily grow in capacity, that is scalability, work rapidly, that is performance, and never or at least rarely fail reliability without any concerns on the properties and locations of the underlying infrastructures. Cloud computing systems can achieve the following 5 goals together. These are data integrity, confidentiality, audit, availability, and control. First one, data integrity. In the cloud system means to preserve information integrity, that is not lost or modified by unauthorized users. As data are the base for providing cloud computing services such as data as a service, software as a service, platform as a service, keeping data integrity is a fundamental task. Next, confidentiality. It means keeping users' data secret in the cloud system. These are two basic approaches, that is physical isolation and cryptography, to achieve such confidentiality, which are extensively adopted by the cloud computing vendors. Next, audit. It means to watch what happened in the cloud system. Auditability could be added as an additional layer in the virtualized operation system or virtualized application environment hosted on the virtual machine to provide facilities watching what happened in the system. It is much more secure than that is built into the applications or into the software themselves, since it is able to watch the entire access duration. Next one, availability. The goal of availability for cloud computing systems, including applications and its infrastructures, is to ensure its users can use them at any time, at any place. As its web native nature, cloud computing system enables its users to access the system, example application services from anywhere. This is true for all the cloud computing system, example DAS, SAS, PaaS, IaaS, and etc. Required to be accessed at any time, the cloud computing system should be severing all the time for all the users. Say it is scalable for any number of users. Two strategies, say hardening and redundancy, are mainly used to enhance the availability of the cloud system or applications hosted on it. And last, control. In the cloud system means to regulate the use of the system, including the applications, its infrastructure, and the data. Next, cloud applications. This includes cloud computing provides dependable and secure data storage center. Cloud computing can realize data sharing between different equipments. The cloud provides nearly infinite possibility for users to use the internet, and cloud computing doesn't need high quality equipment for the user and it is easy to use. And these are some of the advantages of cloud computing, which includes lower computer cost, improved performance, reduced software cost, instant software updates, improved document format compatibility, unlimited storage capacity, increased data reliability, universal document access, latest version availability, easier group collaboration, and device independence. And these are some of the disadvantages of cloud computing, which includes requires a constant internet connection, doesn't work well with low speed connections, features might be limited, can be slow, stored data can be lost, and stored data might not be secure. Now just conclude the topic cloud computing. This presentation discussed about the architecture and popular platforms of cloud computing technology. It also addressed the challenges and issues of cloud technology. In spite of the several limitations and the need for better methodologies process, cloud computing is emerging as a hugely attractive paradigm, especially for large enterprises. Cloud computing initiatives could affect the enterprises within 2 to 3 years, as it has the potential to significantly change IT sector totally. And these are some of the references used to study about cloud computing. Some of the books and websites are given. These are all about cloud computing. Thank you.